about isosceles trapezoid. What do we know about this word isosceles? If we have an isosceles triangle, raise your hand and tell me, what's an isosceles triangle mean? Two sides are equal in an isosceles triangle, right? So if I say we have an isosceles trapezoid and an isosceles trapezoid, two sides are equal here too. So an isosceles trapezoid. In an isosceles trapezoid, we have two sides, and they're called the bases. This is a base, and this one is a base, and the bases are always parallel to each other. So that's how you can figure out which ones are the bases. They're the ones that are parallel to each other. And then these other two guys, these are the ones that are congruent to each other. Those are the two sides that are congruent, and we say those are the legs. Each of those is called a leg. Is this a parallelogram? Are both pairs of opposite sides congruent? No, these are not congruent to each other. Are both pairs of opposite sides parallel? Are these two sides parallel? No, this is not a parallelogram. So it's not a parallelogram, but this is what we do know about it. There is one pair of parallel sides. There's one pair of parallel sides. This is my pair of parallel sides. And there's also one and only one pair of congruent sides. You've got your two legs are congruent to each other. In an isosceles trapezoid, the diagonals are congruent. If I drew my diagonals would be congruent to each other. And fourthly, the base angles are congruent. So if I look at this base, I say this angle and this angle, those are congruent to each other. Those are the base angles. They're both acute. Makes sense when you look at it. And up here, there's two more base angles. These angles are congruent to each other. They're both obtuse. They look like it. We could measure it, and I'll prove it to you in a second. Two examples. Example 1. This angle is 85 degrees, and I'm going to say, find angle L, angle M, and angle N. If it's an isosceles trapezoid, that means these two bases are parallel to each other, right? So go with me a second. If these are parallel, you don't have to draw this on your paper, just watch a second. We've got parallel lines cut by a transversal, so I know this angle and this angle. What's the name of those two angles? What kind of pair is it? They're supplementary, but what's the name for it? Same side. Consecutive interior or same side. These are supplementary. So this one, bless you, plus this one add up to 180, right? So knowing that, we can come in here now, and to figure out what angle N is, I can go 180 minus 85. That gives me 95 degrees for angle N. It's obtuse, it makes sense. It's greater than 90. How big would angle L be? 85. It's the acute one. Your base angles are congruent. And here, this one would have to be 95 degrees. Your base angles are congruent. So fill it in. Angle L is 85 degrees. Angle M is 95 degrees. And angle N is also 95 degrees. Example 2. What is this line in the middle called? Mid. Oh, this is a midpoint, and this is a midpoint, and when we draw the midpoints of the sides and connect them, we say that is a mid-segment. Yes, yes. It's a mid-segment. And here's a formula of how we find the mid-segment, and then I'll show you a different way. Mid-segment equals 1/2 of base 1 plus base 2. Midsegment equals half of base 1 plus base 2. And it doesn't matter which one's which as long as you've got both bases in there. So we plug it in our formula. Half of one of the bases is 12, the other base is 28. Please excuse my dear Aunt Sally. P stands for parentheses. We need to work inside of parentheses first. 12 plus 28 is 40. And then half of 40 is 20. And this is in inches because we were talking about inches. So this segment in here is 20 inches. Here's a quick check. How do we get from 12 to 20? Plus 8. How do I get from 20 to 28? Plus 8. Is it the same on both sides? It's a mid-segment.